So defects in casting. So here we are talking about manufacturing defects. If you remember previously we discussed that there are certain material defects and there are certain manufacturing process related defects and also assembly related and so on. We are talking about manufacturing defects, which means any issues that are due to certain problems during your manufacturing process. So during casting in this particular case, okay. However, some of them may be related to, may be connected to the impurities present in material. But for now, we are going to analyze all these defects according to the final part, or some deformations or some sort of random shapes present in the final part that you have already manufactured. So let's say this is the example. We want to manufacture, or we performed casting to make this block of metal, so which is shown as this rectangle here. You see on top of this particular block, what do you have? You have some sort of these hemispherical shapes, depressions, what I would call. So these are caused by, these are called blowholes, by the way, or just blow in some cases. These are relatively large, visibly, you can see it through the naked eye. So they are relatively large, hemispherical. Not a cavity does not mean it is through, but it is just on the surface. But this is what these are on the cope surface. You remember what is cope? Cope is the top part and drag is the bottom part in your two-part mold, right? So on the cope surface, you will see these kind of structures. Then those are known as blowholes. Okay. You can also have certain slightly smaller than blowholes kind of holes, which are caused by the trapped gases. Now, sometimes your metal itself can have some trapped gases. Sometimes there are impurities in your metal, and when you heat the metal to very high temperature, metal melts, but the impurities may just get evaporated, or they can react with, say, some carbon present there, and that is how some gases may be generated, some gas bubbles may be generated. Sometimes also during pouring you can end up trapping bubbles. So all of these gas bubbles can actually cause what is known as gas holes. So you can see there is some difference between blowholes and gas holes. Blowholes are on top surface mainly. Gas holes are also trapped a little bit inside, but not too far in the bottom, by the way. We'll come to those kind of impurities as well, defects as well. But these are near spherical or spherical sort of bubbles. So these are known as gas holes. Okay. If these gas holes are very, very small, let's say, they are also very close to the surface and extremely small. So you find it difficult to see them through the naked eye, but you can see that there is some roughness and so on. Of course, when you inspect it, you see it using a magnifying glass, or you see it somehow inside a microscope. In that case, you can figure out that there are a lot of holes. These are often close to the surface again, and they are much smaller than gas holes. So basically, these are known as pinholes. So all of these are basically your defects. Okay. Now, if the entire material has become porous, you know what is porous, right? You have holes sort of uniformly distributed. It's like a sponge. It becomes the gas holes, or for whatever reason, if they are distributed throughout the structure, and this could also happen due to issues with your mold itself. In that case, you call this entire structure porous, and this kind of defect is known as porosity. So how do you define it? Very small holes, but they are distributed throughout the material or throughout the casting. Okay. What else? There is something known as penetration. You see these weird tiny little spike kind of things coming out of your on your surface of your metal structure. This is known as penetration or metal penetration. Why does this happen? Well, if your sand is not tightly packed and it allows for some capillary action, the metal can actually get sucked inside. It can actually, when you're pouring it, then it can go through the sand a little bit and then solidify in that shape. And that is when you get this metal penetration. Now it can be on a very small region. It can also be distributed, at different parts of your surface and so on. So this kind of defect is known as metal penetration. What do you need to get rid of it? Well, make sure that your sand is very tightly packed. Okay, fine. What else? This is a very common defect. In fact, it is known as hot tear. Now, what is hot tear? Tear is often the term used for cracks on the surface or cracks of any kind. Okay, so now the casting surface, if there is a lot of residual stress, because of that the cracks can occur. Actually, often cracks occur because of the residual stress. What is residual stress? When you pack something using clay, when it dries up, then often there are cracks formed, right? So this is because of the residual stress. So that can also happen when when something cools down. When this can happen to clay, this can also happen to metal casting. So these are the kind of defects that are known as hot tear. Okay, now this is an interesting one. So the shape now is slightly different. Okay, not it's also, let's say, a block of metal, but I have shown it this way because what I wanted to show is there's a certain type of defect that is on the vertical wall. So that is because of, let's say, little bit of sagging of your mold. So what can happen? So this is basically, it's known as swell, and this is a defect that occurs on the vertical walls of your part, and this happens due to deformation of the sand, which is caused by hydrostatic forces or pressure. So if you imagine you're creating so much, you're pouring very hot metal, and that is cooling down very fast. So there are a lot of hydrostatic forces being generated. If because of those forces the sand displaces, that the sand can kind of gets deformed a little bit, then on the vertical walls sometimes you get what is known as swelling. So this is yet another defect. Okay, continuing with the defects. This is my favorite defect. It is known as misrun. Now you must be thinking that the metal is being poured, it is really hot, and then within couple of seconds what we are doing is we are basically cooling it down. It is because the outside environment temperatures is just the room temperature. Well, yes, sometimes it so happens that the metal, despite overheating or everything, if you have these very thin intricate shapes, and casting is used for intricate shapes, right? So if you have these very narrow channels, long channels and so on, sometimes the metal cannot reach there and it solidifies. So basically, if there are some empty corners, empty ends of your design, because of the fact that metal solidified before reaching there, then that is known as misrun. So here, whatever is the little empty space, basically that is where your metal could not reach. So this is if you have one-sided sort of, if you had only intricate shapes on one side. If you have two gated structures, double gated structures, what does that mean? You remember what is gate? Gate is this narrow channel through which your metal just enters your structure or your the pattern cavity. So there, if you have two gates, in that case, sometimes the metal is coming from both sides, and before reaching the center, it can get solidified. So sometimes the same kind of thing which you saw in misrun in the corners, if you have double gated patterns, this is expressed at the center because the metal is coming from both sides, but before reaching the center or before completely filling your pattern cavity, sometimes it can harden, it can solidify. So in that case, there are some defects in the center or in the middle of your structure. That is known as cold shut. So cold shut can be defined as a type of misrun, but in double gated structure. Okay. What else? Shrinkage cavity. Shrinkage cavity is relatively easy to understand, right? We already know that shrinkage happens often in the center of the structure because near the walls the solidification first starts, and then towards the center then there is some cavity created. Now what we do is we fill the metal again using the riser, but if it is not properly filled, or in the riser also if it solidifies, so in that case we may end up getting shrinkage cavity, and that is how it looks like. Of course, there will be a certain depression near the center or close to the, depending upon the shape of your pattern, it will be somewhere in the center, in the middle of your structure. Okay, what else? There is something known as drop. So drop is more like these randomly shaped structures, and they are often on top of the surface. And why do we call it drop? Because they are caused due to, your sand dropped a little bit from the mold. Okay, so these are irregular shapes on the cope surface or often on the top surface, right? caused by dropping of the sand a little bit here and there. Again, the reason is that your sand was not properly, it was not tightly, bound enough. Okay, so these kind of irregular shapes are known as drop. Wash is another type of defect, which is, you see, there is a gate I have made there. Near the gate, there is some sort of bulge, downward bulge. And that happens because, you see, your the velocity of your metal is changing. In the beginning, you had relatively very broad, where, the place where you were pouring your metal from, the initial cavity. Then it goes through runner, which is narrower relatively. Then it goes through gate, which is much more narrow. So now the velocity is increasing, and there is also sudden change in the behavior of your metal in the gate. So sometimes because of that, there is a little bit of displacement of sand, and that can cause these kind of depressions or these kind of downward projections near the gate. They are known as wash defects. Okay, now last two, one is known as mismatch, and the other one, which is also a type of mismatch, is known as core shift. So what is a mismatch? This is very easy to understand. You have the top part, you have the bottom part, and we are like opening and closing them, cope and drag, right? So if when we are closing them, they are not properly closed, there is some sort of displacement in closing it, which can be even a couple of millimeters, by the way, not so much. So those couple of millimeters also can actually cause a mismatch in the top and bottom shape. Let's say you have this, and then you can have something like this. So that is known as mismatch, also sometimes called mold shift. Okay, now there is a different version of it. If you're making a hollow structure and some mismatch takes place, in that case you may end up shifting the core of your structure, so you can get something like this. So these were all the defects, but actually there may be some more defects which you will find, so I have mentioned the book, which I also told you can use as a textbook, Professor Ghosh and Professor Malik's book. This book describes some more defects, maybe a couple of them which I have missed out. Also on the internet you can find many other defects which people have mentioned based on their personal experiences, and also based on different types of designs. But these are the primary defects in casting.